Thank you so much, and welcome everybody. If you're just now joining us for our Play Day webinar, thank you for attending. Just a couple housekeeping items before I hand things over to our next speaker. The webinar is being recorded, like we mentioned. We're going to be posting the slides and video recordings on our website and YouTube channel shortly. Look for those in a day or two. If you have questions, myself and another member from Gilt are going to be taking a stab at the question pod throughout the session and saving a few for a Q&A at the end. Hopefully we get to all of your questions. If not, Giancarlo, who I'm going to introduce in a moment, will get back to you directly at the end. So with that, I'm going to hand things over. Giancarlo Silvestrin is a senior software engineer at Gilt, and he's going to be presenting how Gilt Group uses Play. The title is Lessons Learned from Implementing Play Across Lots of Small Applications and Microservices. Thanks so much, Giancarlo.
Hey, Laura, thanks for having me. I'm really excited to be presenting here today at Play Day. I'm going to share my screen.
To have you. Great.
Can you see my screen okay?
Yep, I can see it.
Okay, so today we'll be talking about Play at Gilt, our users, how we implemented it, and exactly where in our stack Play comes in. A little bit about myself. My name is Giancarlo. I'm a senior software engineer with the personalization team here at Gilt. Originally a Java developer, like so many Scala developers nowadays, and turned to Scala, turned to the Typesafe platform, and I'm really happy that I did. So today I'm going to present our usage of Play here at Gilt, why we chose it in the first place, where are we using it, exactly which points did we have to extend to cover all of our use cases, and also I want to touch a little bit on the future of Play here at Gilt and where we are going in a general direction. So a little bit about Gilt. I know that many of you don't know much about the website, but Gilt is an e-commerce company. It's one of the top 50 e-commerce companies in the world, and it operates in a flash sales model of business. And what this means is that every day at noon, new sales go live to the website. So these sales, they usually have some common characteristics. There is limited inventory. There is usually huge discounts from retail, and also some items are seasonal. So there is really an advantage for the members to come in really quickly and buy the items, otherwise they can be gone forever. So as I mentioned, there is this new deals released daily, usually at noon, creates a sense of urgency. And another way of looking at it is that our traffic increases so much around noon. This is where Gilt makes most of its revenue. This is where we have most of our page views, so it's really important for us to have a solution, an architecture that can scale to handle all of these members coming all at the same time. A little bit about history, about how we ended up choosing Play and choosing Scala. Gilt was founded in 2007. It adopted a traditional Ruby on Rails architecture, which was all the rage back then. So it was really simple. Just had a Postgres was chosen as the database, a single Rails app that handled logically all pages of the website. There are some layers of caching, and this worked great for some time. We were able to build Gilt, we were able to scale up to a certain point. Of course, eventually, we hit some scalability challenges. The number of Gilt members was increasing as they all come to this website at the same time. It was becoming hard to keep up with the demand. Database was overloaded. We had to run thousands of Ruby processes just to be able to handle the spike. Clearly, we needed a better solution for that. But also, we had a different kind of scalability challenge. That was the fact that a monolithic code base was making too hard for making changes in the code base. We have now over 150 engineers, and of course, if you want to coordinate changes in a single code base, this becomes harder and harder every day. So we solve these problems in two different fronts. One of them, we start switching to the JVM. Why we did that? The JVM, to us, provide a better platform for running long-running process. It was just more stable overall. It had a better garbage collection. With the same hardware, we are able to handle the spike at GNOME, so this really works for us. And initially, we chose Java as our language of choice. Of course, as coming from the Ruby, Java felt too verbose. It was hard to write and read code, hard to test. So we're happy to pioneer Scala usage here back in 2010. The language felt more dynamic. It runs on JVM. It's compatible with all libraries that we use. And Scala is now the default way for us to build applications here at Gilt. We also, at around the same time, we started to change the architecture of the website. Portions of the logic that were all part of the same application were moved to service, and we call the service microservice. They can be deployed. They can be developed individually. They sometimes have their own databases, but really the key advantage for us is that reduces the unit of deployment to just a service where there is clear code ownership, and also there's this isolation that I mentioned where we can develop, test, and scale each service as needed. We started with a few services. We have over 250 services in production now, and it's growing every week. Every time that we want to add new functionality to the website, we build service to provide them. After we moved to microservice, we still had a problem with the web app, even though we had portions of the logic divided within microservice. We still had a monolithic web app, and we wanted to reap the same benefits that we had from microservice move in the web layer. This is where Play comes in. We call this type of applications LOSA, just a short for lots of small applications. And what we did was breaking down each part of the website into an individual application. We get the same benefits of microservice, but for the web layer. It's another area that's growing fast. We have over 75 apps with over 70,000 lines of code, and not even including JavaScript or assets. This is just Scala code. So in order to give an idea about what I'm talking about, I'm going to do a live demo. So if you go to the Gilt website, usually you start in the home page, and then if you check the top left corner, there is a name which says Web Homepage, and this is the name of the application that I'm in right now. As you browse through the site, you see different applications are invoked. For instance, right now I'm in Web Mosaic. I can scroll down. Maybe I select a sale that I like. I go in, and I'm in Web Search. After that, I can select finally a product that I like, and again, a new application will be handling this request. It's Web Product Detail, responsible for showing pictures, descriptions, and whatever other information the product needs. So even though there are different applications, they all share the same look and feel. They share the same resources. But of course, we get the benefits of being able to make changes and be able to test and deploy them in isolation. Okay, moving forward. The first Gilt project was really about creating dynamic experience for our users. A team of passionate developers here at Gilt wanted to explore WebSockets and other push mechanisms to give better visibility about what's going on inside the site, since so much happened in such a short period of time, usually around noon. The first of such projects was Gilt Live. It shows in real time the sales that are happening on the website right now. So each time someone places an order, you see what is here. This is an interesting concept. You can actually see what popular items are being sold and provide a different kind of discoverability for what's in the website. Another project was to provide live inventory updates. I mentioned that inventory usually is limited. So for the members to score the best deal, they really need to be proactive and look for products that are being close to sold out. So a typically flow would be that a product is close to sold out, so we just have one item. It becomes reserved, and then this means that all products are being placed inside the shopping cart. And at this moment, we update live the mosaic and the product listing page for the users, and eventually all items will be sold out. And this is going to be updated in real time as well. So this is how we started with Play. One of the reasons that we chose it in the first place is because it has this great WebSocket API. For people not familiar with it, this is how you could implement a simple echo endpoint using WebSockets in Play. Since WebSocket is a two-way communication with the browser, you need an input and an output channel. So for input, you use an iterative, and here, every time they receive a message, we just log it and push to a channel that was created with the output channel. So every time we receive a message, we just output back to the client. It's really easy to get started, easy to implement, easy to understand. So that was the first use case we had for Play at Gilt. So from that point forward, we started to expand the usage here. The expansion was mostly organic. People were choosing Play. People worked with it a little bit, saw the benefits, and started adopting it. Right now, we're using Play for all our other apps, including critical parts of websites like search, product listing page. We also have some internal apps that we manage inventory, what sales are go live to the website, and we are increasingly use Play for them. And also, there are quite a few microservices that are built using Play now, and I'll touch on them back a little bit after. So just going to touch on the points, some of the points that made us Play such a great fit for us, what the benefits we see here at Gilt and why we adopting it. First of all, since we adopted this service-oriented architecture, it was crucial for us to be able to move to this reactive model of programming with asynchronous requests being dispatched to several services at the same time. Since in a service-oriented architecture, each machine, each controller will spend most of the time waiting for other nodes to respond. Play's web servicing is really easy to get started. It's really powerful, and it does everything that we need in terms of creating requests and make sure that we can collect them all together. Another aspect of this architecture is the non-blocking nature of when you're waiting for remote requests. You don't want your controller to be holding threads or any other resources. You want it to be free to respond to other requests. And we saw the benefits of this architecture pretty easily. We have one app that used 32 instances, and we are able to reduce to just 8 after migrating to Play and adopting this reactive way of creating applications and programming. So it was really a good fit for us because of architecture. This is a simple example about a user profile controller. Here I'm saying that this request will be async. This controller is async, so this means that the response will be asynchronous. I start by creating 2 service calls, one to get the user information and another to get the groups for this user. And here I just instruct Play that after we get a response for both calls, it should finally build a response and send it back to the client. Of course, it's important to notice that in any time Play is blocking, waiting for the response, it's all chained together in a nice async way. It took us some time to actually move all the way for this style of programming. There is, of course, a learning curve to understand exactly why you shouldn't block inside a controller, why you need to do this sometimes extra work still have asynchronous communication. The code can get messy with callbacks if you're doing a lot of asynchronous calls. And I think this is a place where Scala shines the most with this feature library, its for comprehensions. It really helps to make the code clean and manageable, even when you're doing a lot of different things in parallel. Some things to keep in mind is that you need to be extra careful for any blocking I/O that your application is doing. Database drivers are a good example, but sometimes you're just using a third-party library, and under the cover is calling any I/O, a logging library maybe. So it's not always obvious by looking at the code that the I/O is happening, so you need to be extra careful with it. And of course, when you need to block, it's useful to know the place thread pools, and especially where you're blocking. Make sure that you're not using the main thread pool so you don't block plate for taking care of other requests in the meantime. Scalability. Scalability is a big reason why we use Play, and really there are two reasons that we like it so far. One of them, Play is built on JVM. It uses Akka. It has great support for concurrence, parallelism, and it really scales up with your machines. By just tweaking some configuration parameters, you are able to take advantage of the multi-core machines and servers that we use here at Gilt and I guess elsewhere. Unfortunately, not all frameworks can say the same. Node.js, for instance, is notorious for being single-threaded, so we appreciate Play's capability of really scaling up for the machine. On the other hand, Play's shared nothing architecture means that we can build and start instance to scale out our service and applications. As you saw in the beginning, we have this big spike at noon where we sometimes need to bring extra capacity from an external cloud provider. And the ability to just start as many instances as we need and make sure that and know that everything will work, it's a big plus for us. Productivity. This is a topic that with every developer that I talk about here at Gilt, this is usually the first thing they say. I mean, how productive they feel programming at Play. Some quote from our developers here is some feel more productive now in Play than in Rails. And there's one developer in particular that said that you could not make him not use Play. So this really explains some of the part about why people keep choosing Play for all applications. I mean, not only scale, not only provides all the scalability and performance that we need, but also the productivity on top is really it's a great whole package. One of the examples is the code auto reload. As we are writing Scala code, I mean, sometimes you have to stop what you're doing, compile the code, and restart the server. Play does this automatically for you, so you don't need to take care of this. Sometimes it really feels like you're working with a dynamic language, even though you're getting the benefits of compilation of statically typed. So really increases productivity from developers. We are particularly fond of the Play JSONs library. So if you have a model like this person here, you can create a formatter for this person in just one line. These formatters know how to read and how to write the model in JSON. And from then on, your controller only needs to ask the JSON library to transform it to JSON. It will use the implicit format that's in scope and really provides this clear abstraction. You clearly can see where the model is, where the view is, and where the controller is. You can test it in isolation. It's really a great design. We use it here for most of our service. I think documentation is also a plus for the Play framework. Most of our engineers here at Gilt are generalists, so which means that we move around from back-end development to front-end development. We are not always experts in web technology, and the fact that most of the Play documentation don't assume that the reader is an expert I think it's a big plus. I really like the async HTTP programming section of the documentation. It explains not only how you can implement the async functionality, but also why you want to do it in the first place. Of course, there's always room for improvement. Some newcomers find it easy to understand JSON from the documentation. I think this is a shame because it's a great library. It's really easy to use. Once you get the hang of it, it has a balance between being simple to use but also powerful to extend if you need it. Okay, so these were the reasons why we use Play. In some aspects we had to build ourselves, or we deviate from the standard Play way of doing things. I want to go through just a couple of examples and explain why we made those decisions. Templates is an example. Play template language, it's great. I mean, it's really powerful. It's based on Scala, so we are all Scala developers here. We could use the same language for building applications and in the view. Also, it's Typesafe, so you can catch errors at compiling time instead of a runtime. So really, coming from a back-end development, I think Play templates are great and really help to catch errors and build applications. But of course, Gilt has some different needs, and the first of them is client-side rendering. Like many other websites, we want to make the experience more dynamic. We want to avoid full-page refreshes. So this means that a typical use case, the first view will be rendered server-side, but from then on, I mean, if the user scrolls down, everything will be switched to client-side rendering. And also, we have some opinions that even here at Gilt are not absolute, but the idea is that the view layer should be simple, and having all the power of Scala, it really can make some developers go a little bit overboard and implement a lot of logic inside a view where it should be elsewhere. Our solution for this problem is called Handlebars.js. It's open source GitHub, and basically it implements handlebars and mustache templates in Scala. For those not familiar with it, mustache templates are really simple. Here is an example that renders a name and a hometown and iterates through a sequence of kids. The idea is that you don't have a lot of logic inside your templates, but also that you can reuse the same template in the server side to render the first view and continue using it on the client side. Another aspect that we had to build our own is the asset pipeline. And the main reason for that is because we have lots of small applications, but they all share the same resources. They share images, logos, and code, some JavaScript utilities. So right now, these tools, they live in a separate repository. They are managed using different tools, which for most part right now is Rake, but we are slowly moving towards Grunt. We had to build an extension to SBT ourselves to call these tools as part of our compilation pipelining, basically to do JavaScript minification, concatenation, upload resources to CDN, and so on. Another interesting thing that I found out while creating this presentation actually is just a huge amount of build tools that exist written in JavaScript. There are some famous ones like Grunt and Branch, but there are a lot of newcomers like Gilt and Fez and Broccoli. It really seems that it's an area that's changing often. There are new tools being created each month almost. So front-end engineers want the freedom to pick up their own tools, and if something better comes along, maybe adopt it without having to wait for the web tier being updated for a new version of Play or something like that. That being said, we are really excited about Christopher Hunt's work with SBT Web. We are looking at it closely, maybe something that we can leverage for our own asset pipelining capabilities and make it more standard. I'd like to talk a little bit about the future of Play here at Gilt. Those apps will continue to be built in Play. We have some groups that are exploring other language, as we always have. We have groups exploring Node.js. We have some group that's really passionate about Clojure as well. But the interesting part is that Play is increasingly being adopted to create microservices as well and the service tier. Even though the service tier doesn't need to render HTML, doesn't need asset pipelining, and really doesn't need most of the Play functionality, having a standard way, having the same framework in both sides, help us to share code, really master the framework and know how to scale. And as I mentioned, people really like the productivity that they get by writing Play applications. And it's becoming the default way of building applications, no matter if it's in the web layer or service layer here at Gilt. I would also like to share a little bit of nascent work that we are developing internally. We call it API doc. And the main idea is to describe a REST API using JSON. So it looks like this. This is a model for a user. So the user has a GUID, an email, name, and an image. But you also describe resources. So for the user model, there is a simple get by GUID that returns the user. So what this provides us is really a focus on the API and on the REST layer. And from this schema, you can generate simple clients for Play and Ruby, route file for Play if you want to implement the server side, a great online documentation, because we think that this is key for the adoption of service, having a great online documentation. And we are packaging everything together inside an activator template. So pretty soon we'll publish it and you will be able to try on your own. Like just to go to the API doc site really quickly. This is how it looks like. I'm going inside the Gilt organization API doc. You can see here that I have a bunch of modules. I can scroll down and figure out exactly the documentation for each attribute, what operations I can use inside each model. But also here at the top, I have the code generation for Play and Ruby. So this is how the route files look like auto-generated, and this is the Play client web servicing. So we're really excited to continue exploring this. We think that focus on clean and well thought of APIs is really key to be able to use the lots of service that we have. So we really focus on this right now. I'd like to thank everybody for tuning in. If your idea of fun, if you want to have fun writing loads of apps and microservices, we are hiring. Follow our tech blog or send me a message. And I'd like to open for questions now.
Thank you so much, Giancarlo. That was wonderful. And yeah, let's take a look at some of the questions. So Lori Apple, who's also with Gilt, has been addressing some of these in real time as we have gone through. So, but some of the responses might be interesting to the rest of the attendees. So, first question here: how do you manage product availability? Is there must be a single point? Can you elaborate on that, Hello?
Are you referring to product inventory?
I believe he's referring to managing user sessions. Let's see. Yes.
Okay.
He is referring to product inventory.
Okay. Applications that need to have state, for instance, the cart, they have their own database and they have their own schema about how to manage this. Of course, there are some cross-cutting concerns like authentication, and in that case, they all share a single authentication service to make sure that the client is who he claims he is. Is this too vague? Does it answer your question?
You know, it might be worth following up offline so that he can better understand, or you can better understand his question, and you can have a deeper conversation. So we can set that up. In the meantime, let's move to the next question so we have enough time. Do you support older web browsers with an alternate to WebSockets?
We do have a fallback for using comment for other browsers, but yes, the experience is usually enhanced by using WebSocket, but we provide the same functionality, either using comment or long polling, or sometimes even doing a full refresh of the data.
Cool. Let's see. So did you consider using something like Swagger before you decided to implement your own JSON API documentation?
Okay, that's a great question, because it was the same question that I had when I first saw API document. Why re-implement it? As I became more comfortable with it, I think the main difference is that API doc focus on REST endpoints. It's really opinionated that REST is the best, or at least is the way that we at Gilt build web services. And even though Swagger doesn't make this choice for you, it's flexible in the sense that you can implement any kind of API that you want on top of it. I think that's the main difference. But that being said, I mean, we're a big fan of Swagger. I think they have a great documentation. It's a great product. I mean, I really like it.
Cool. Next question. What do you think about Yeoman for, I'm hoping I pronounced that right, for front-end automation? Are you familiar with that tool?
I'll have to follow up with this offline, because this kind of tools usually our front-end engineers are more comfortable with. I'm more of a back-end engineer myself, but I can follow up with this later.
Okay, great. So next question, why not use cookies for state, like card?
Okay, we do use cookies. Maybe I should be more explicit. Of course, we do use cookies, but usually to track the user itself, the cart, and all this kind of data that really needs to be persisted. If the user, for instance, logs out or switch browsers or go from mobile to the web, this kind of information we usually persist inside the application, because you don't want to put this inside a cookie, and if the user now that he starts buying something on mobile and switch to the desktop, we want the checkout cart to be available, always available.
Okay. Do you use Deadbolt for authorization?
That is a good question. I do not know that. I mean, I'm not familiar with this part of the authentication mechanism. I believe it's just a simple session-based authentication.
Okay. Well, there were a couple questions about the authentication mechanism, so maybe we can follow up with those folks offline too.
Okay, yeah.
All right, let's see.
Oh, there is one good question that asks if it's 250 different microservices or 250 servers for a few service. It's really 250 different microservices, 250 different code bases, and each microservice is deployed to a cluster of servers, of physical servers.
Okay, thank you for clarifying that. And I guess his follow-up question was, how do you orchestrate?
We usually use the controllers themselves to orchestrate the calls to multiple services. So this is mostly the logic that we put inside the controller. And the actual business logic, this lives within the microservice and are exposed through a JSON API.
Great. Well, I think some of these questions might be best for you to take a look at via email and follow up with some people. So let's wrap up this session for today. Thank you so much for your time. Really enjoyed your presentation. And if people have other questions, they can either send me an email directly, and I can put you in touch with Giancarlo, unless, Giancarlo, you want to share any contact information with the audience.
All right. Thanks again so much for having me, Laura. Really excited to be here today.
Wonderful. Okay, thank you so much, everyone. You have to log off in order to join the next session. We're going to take a short break, about an hour, and we'll be back with Christopher Hunt, who's going to be presenting from the Typesafe team. So we'll all talk soon. Thanks so much.